Welcome back to the final part of this How It Works with Holger tutorial. So far we've created the XData server that allows us to create charts inside of a web application really easily. And just to show that XData works universally, we created the first web application in vanilla JavaScript. We've seen the struggles that we have there because we work with an untyped language that is not getting compiled. So during the process, you saw that I made a couple of mistakes that only showed up at runtime. We didn't notice these errors right away. The application just didn't work, and I got errors in the console. All this can be prevented by using TMS Web Core with our favorite language, Delphi or Object Pascal, and having a compiler that checks our web application before we actually present it to the web server and then run it inside of the browser. Let's do that. Let's build this TMS Web Core application that does the same thing as the vanilla JavaScript application. Also, we will use or reuse the design that we already created inside of Visual Studio Code. This is the first step. I will show you how you can migrate over your HTML and CSS. There is no CSS in this case. The CSS comes from Bootstrap. I will show you how you migrate that over into a brand new TMS Web Core application, which we will build from scratch. Our project group already consists of our XData server, and you can add a new TMS Web Core application to this project group. You can say add new project by right-clicking on the project group that doesn't have a name yet, and then you can click on TMS Web application, and it will be added to the project group. The same thing to do is after adding the project, just pick Save All, and then go to the directory, to Web Core, save your form main, that's the first one. Then the index.html, that's our root HTML. And then the project name is going to be stock service.web client, for example. Save. And now the name for the project group, we go into the stock service live into the top directory and say stock service project group. So we start with the web client now. We also assume that you have your server running on localhost 80. That's what we build it on. And then we close this and we go into the index.html. That is the file. When you run your web application, that's the first thing you got to try. If your system is set up correctly, you should be able to see localhost 8000. That's the default setting from TMS Web Core, and a white page. You should not get an error message, and you see that the endpoint that is getting used is the index.html file in this case. So we go over to Red Studio again, and this index.html file, because this is a single page application. All TMS Web Core applications are single page applications. This is the HTML document that will be the only HTML document loaded by a web browser when you launch your application. Because what happens is it always replaces the HTML code between these body tags, and the replacement is done by the script that is referenced here. So your TMS Web Core application will always be on this endpoint. There is not another path on your web server that is getting used. It will always be this index.html file that is getting re-rendered, so to speak. Its canvas is getting re-rendered, or to be more technical, the DOM is being, the document object model is being modified all the time in order to present different user interfaces. This is a clear separation from other web frameworks, but TMS Web Core uses the single page application approach. So with that in mind, we need to reference all the CSS and all the frameworks we want to use in this index.html file. So I remove the style here. And the first reference I need, of course, is Bootstrap. The second reference I need is the chart.js reference. I copy those over from Visual Studio Code. So here, from the HTML document, I have the reference to Bootstrap, and I have the reference to chart.js. I no longer need the reference to my application that I created, because that's exactly what we implement now with TMS Web Core. And then we also need the script reference from Bootstrap, which we can add at the bottom of the body tag right here, in between here. As said, modern browsers, you can also do defer at the end and then move it from here into the head. What that does is it means that this script is loaded before the body. Usually it's literally the order that it comes in. It means like the body is loaded first and then your script is loaded. In this case, because of the defer, your script is loaded right away before anything in the body happens. So that might be what you want to do. So with this cleaned up, this is your index.html file that loads Bootstrap and chart.js and also the scripts that we don't really need in this example, but it's always good to reference everything that Bootstrap has to offer in case you extend this project at a later time. We save this, and at this point we no longer need to touch the index.html file. Now to the main form. The first thing we need to do, we have to flip this to CSS Bootstrap. By the way, this would be the same for any other CSS that you use. The CSS Bootstrap just flips the element font and other properties so that it's being used from the CSS and not from the object inspector. That's basically the only thing we want to achieve here. And then we do name form main. And then the main form also has an HTML file. And this HTML is then rendered. I said we no longer touch the index HTML. For explanation, it's good to explain this comes in here. So whatever is in between here goes in between here. So what we do here, we remove everything that is in the template, and instead we're going to insert what we have in our Web Core design that we created in Visual Studio Code. So what we do is we go into our vanilla JS layout right here and copy this layout. Let me extend the size a little bit. This HTML, we copy that, everything that's in between the body tag right here into that document. Like so. That's it. Copy. And then I paste this in here. Paste. And yes, I can really do it with div to div because everything that's in between, that's in this file, gets inserted between the body tag right here of the index.html file right here. So that's the reason why I can do it this way. Okay, so save. And if I start my application now, I should get the user interface that we had before. Perfect. See, I have the user interface. Of course, we haven't written any code. So this combo box is empty, this combo box is empty, and this will trigger an exception because right now inside of the HTML there is an on-click event defined. So if I click this and go to the console, I should get an error because show chart is not defined. And that's something that we need to change. We take this away, show chart, remove it. Instead, we're going to use TMS Web Core to achieve this. What I mean is we go to the designer and then add a button. And this button, because we have set this to CSS Bootstrap, gets predefined with certain element class names. We don't want that. Remove it because everything we want is already in the HTML. The only thing we need to do, element ID, we need to hook this up to the button, but we don't have an ID for the button. So we go into here and then button, we say ID equals button, create chart, for example. We save this, and then we go back to the designer, click on element ID, button, create chart. And now this control becomes this tag. This is what it does. So you basically say, hey, this is just the thing that I can access in Delphi, but essentially it becomes this tag in code. The downside sometimes is that this caption sometimes overwrites what we have in here. So the good thing is you either remove the caption or do the same caption as in the HTML. And with that, I can double click and do an on-click, and when we also rename the button, this is the name that it has inside of TMS Web Core. So I say, for example, button show chart. And then here I say show message, it worked. Or better, console log, it worked. Exclamation mark. Show you what that does. Or restart the application. And now if we go with F12 into the developer console, I click, it says it worked. So now we have linked the button that's inside of our HTML to control inside of TMS Web Core. This way you can link anything that is inside of your HTML to controls inside of TMS Web Core. I just want to point that out. This is also possible for edit controls, also possible for this combo box, for example, but I'm going to show you for the combo boxes, we're going to use the same approach that we used inside of the vanilla JavaScript example, because I think it's faster instead of dropping controls here in the designer, but that is personal preference. You can drop all the controls that you want to bind from your HTML and then work with the properties and events inside of the object inspector if that feels more natural to you. I'll give you both options in this example. So this is the option for the button click, and we definitely want to call show chart in there. So we have to obviously define show chart. This is Delphi, so we don't need the braces, but what we need to do, we need to define it. So we go into the private section and say procedure show chart. And we might use asynchronous operations in there, so we say async. That way we are able to use the await function that is part of TMS Web Core to await for asynchronous processes to finish and then continue code execution inside of that method. If we don't have the async tag in front of our procedure, we can't use await, and that would make our code much more cumbersome to write. What we also need, we need references, just like in JavaScript, to the chart. And the chart is a TJS object, right? And we also need a reference to the fSelect symbol. And the fSelect years is a TJS HTML select element. What are those? Those are, we go to the browser, this and this. You can bind them through the JavaScript components, so to speak. So TMS Web Core also has a mapping to all these HTML elements, not just TJS element, which is like the general type. No, you also have TJS HTML select element, and all the other tags usually have a representation as well. Don't get confused with the F chart. We're going to do something more sophisticated in this tutorial than I've done before. Just as something that you can see, you can even abstract from the 1 or 2 lines of code that you have to write in JavaScript so that other developers don't have to write JavaScript if they want to use your things inside of TMS Web Core. So that's the first thing that gets called from the button. But before we can do that, we need to connect to our XData server, because this is the wonderful thing that we have available now. We have the XData components available. So we no longer need to guess the URLs, the service endpoints ourselves. We can use TMS XData to do that for us. So we use a TXData web connection and a TXData web client to issue the requests. So these are dedicated XData components. Instead of using the HTTP request that we manually create, we use predefined components that come with TMS Web Core. The connection, we're just going to name connection, and the XData client, we're just going to name client. What we do is, if the connection has been established, we use the onConnect. What do we want to do as soon as we're connected to the XData server? And please don't think of the connection as it is a connection that stays established. It's just a term or a component name that was used to refer to the Delphi way of doing things. There is no constant connection to your XData server. All it does is if you connect to your XData server, it reads the meta information from your XData server. Let me show that real quick. What happens is it reads localhost /$model. This is the description of your web service, so to speak. And with that, XData can read, oh, there is a stock service, it has a symbols function, it has a years function, it has a line chart function with these parameters in here. That's the reason why you connect to an XData server. Technically, it means it reads the model into memory so that if you have follow-up calls, you just can say, I want the iStock service symbols or I want the iStock service years, and you don't have to specify any of the HTTP paths. Instead, that's what XData derives for you. You'll see that in a bit. But just please don't assume you have like a connection that is established and that stays open. That's not the case. There's just a couple of requests that go back and forth in order to determine what your XData server is capable of. So when we are connected, what do we want to do? Well, I want to initialize the interface. So I call init interface. And what I do in the method is I want to fill both combo boxes with the information that I need. So in here, I'm going to say async again. I'm going to say procedure init interface. Okay, so Control-Shift-C. That implements all those methods. In order to connect, what do I need to do? Connection.connected equals true. That connects to the XData server. And how do I trigger that? Well, the form has an event on DOM content loaded. That's the one that I'm going to use. As soon as the form is ready for me, then I want to connect. Perfect. So that's set up. And with this, I will just see init interface. I'm going to say here console log init the interface. And if I now run this, you will see that this is triggered automatically after a while as soon as the form gets loaded. So if we go here, you see that I get an error. What is the error? 404 not found. What is not found? Well, if we look at the XData connection, I did not specify any URL at all. That is just localhost. Because localhost port 80 is our XData server. That means I could also specify localhost 80 and HTTP localhost 80, for example. Okay, now I run this again, and then we will definitely connect to the XData server. I'm pretty positive it will work this time. With this, I don't get an error message, but on the network tab, if I start this again, we get the ominous request to model that I hinted at. And also, if we go to the console, we get init the interface, which means we reach the position in code in order to initialize the interface. And here we have to do two things. Request years, fill combo box with years, and then here request symbols, fill combo box with symbols. That's it. Those are the two things. The request years, how do we do that? Well, we have the client right here, client dot, and it has a method raw invoke async, and we can specify an operation ID and the arguments. And the operation ID, we get that from our Swagger. So we go here, localhost 80/Swagger UI. Then if you look, for example, we want to start with the, what do we want to start with? With the years, yes. Go to the years, and there you see iStock service years. That's the operation ID. That's what I would need to copy. It's not possible to copy paste because it's clickable. So just remember this. And it's also derived of the interface that we use in the service definition, because the interface is iStock service. That's the name of the interface, and years is the name of the method. We didn't make any changes. If you look at advanced XData technology, you can change these. That's a hint I'll have at the end of this course, where you can get more information about advanced features. So here, stock service years is iStock service years. That's what we need to use. So I say iStock service dot years, and we don't have any parameters, and that's it. And the thing is, I said async, so this has to be wrapped in a wait, and the response is L years. Response is a TXData client response, because the component is the TXData client, and this is the TXData client response, L years response. And this will fill up the comma box with years if L years response status code equals 200. 200 means it's a successful response. And what we need to do now is, if you remember, looking at the response here, we have value and a list of integer values. So what we will do is we have the L years array. That's a TJS array. And then we can do the following. We can say L years array equals L years response dot response as object. From that object, we need the value property, and we need to cast that to TJS array because it's a JavaScript array. And now we have each of the elements is an integer that is supposed to be added to the selector. And let me just console log this. L years array. And we stop this again to take this really, really slow so you can see the process, what is happening. Don't let error inside confuse you. Everything in this code is fine. You might consider switching off error inside for TMS Web Core projects. And here, now, oh, we have an error in here. Missing its data connection. Okay, see, I'm really taking it step by step. This connection is here, and this client needs to be linked to that connection, like this. Otherwise, it doesn't work. Start again. See, this is really a learning experience here. Even I mess up. And no error message anymore. And if we go now to F12, on the console, we see the array, and we have our years that have been returned from the web service. Also, if we go to the network tab and reload the page, we see that the chart.js is loaded, Bootstrap is loaded, our model is loaded, and then the years get requested. And this is literally the response that we get for the selector. And with that, we can now fill the years into the selector. And that is the tricky part, right? We need to find the selector. We already have the variable right here. So fselect years. Fselect years is document get element by ID. And what is the ID? Well, we have that in our HTML, right? So here, select year. That's the ID of that element. And we also need to cast this. So it's a TJS HTML select element. Perfect. And now we can add to that element option elements, right? Because the options, if we look at the HTML again, these options here are what we need to add to it. So the value has to be 0 here. I don't know why I keep writing an asterisk there. 0 means all. And then the other options will be the other years. So with that in mind, I can iterate the array. So what I need first is a year, and the year is of type integer. So we do L year is of type integer. And I also need a counter variable, I think. Well, actually, it should be easier than that. I should be able to do for L year in. No, because it's an integer, I don't think I can do that. So what I do is I do a very traditional loop for I is 0, 2, and then the length, L years array dot length. Even though code completion does not show this and it is marked as an error, this is the correct code, okay? Don't let error inside annoy you. It is correct code. And the year, the current year, is L years array, and then I, And then we have to cast that to integer because every element by default is j as value, meaning any value. And then the option, that is something we need to create. L option is a TJS HTML option element. Perfect. So that basically renders to this kind of element, if I can type it correctly, option and option. That's what happens with a TJS HTML option element. Okay, and from there we can say L option equals document create element. The tag name is option, obviously. And then we have to set its inner text, not inner HTML, is L year, the year as a string. And then the value, very important, is the same though. The value is also L year dot to string. Perfect. And the only thing remaining now is to add this option element to the select tag. So f select years dot append child and then L option. Perfect. That's it. Let's test it. We should see now all the years inside of our select tag. Right, we get an error. What does it say? Oh, of course, we need to here TS TJS HTML option element. We need that typecast. Okay, perfect. Now it compiles just fine. Okay, and now if we expand the years, there we have all the years and not a number. What did I do wrong? Of course, length -1, right? Because we go from 0 and length is the total length. And thus I need to write -1 and then the list will be correct. Okay, and this is literally something we can copy paste more or less. We can do the same thing for or just like with JavaScript, we can do exactly the same thing. We get the symbols and we get afterwards we build the select query for that. So what we do here is, so we do a L symbols response, we do L symbols array, and we do an L symbol, which is a string. And then I we can reuse, and the option element we can reuse as well. So the only difference is that we have to basically here, and we request the symbols. We do L symbols response. And then here we do, not years, we do symbols. That's the first request, or the second request, I should say. And then we fill only if L symbols response dot status code equals 200, then begin. And then we do the same thing as above, just like with the symbols. Copy. If you wonder if you can do this more generically, I'm sure you can. Symbols response. And this is a little bit different, right? So we have the L symbols array, and then the F select symbols equals document select, symbol, select, what is the HTML component called? Select symbol right there. So we copy that over to here. And then we have the, not the L years array, we have the L symbols array, length -1. And then we do the L symbols array I. And here it's a little bit different now. We don't have an integer that we cast to. We have instead the symbol is also not a string, it's a TJS object, remember? So we have an object. So we do here is L symbol. We have to find the right one. No, yes, L symbol is TJS object. And then here for the option, we have L symbol name to string, or you have to do it the other way. This to string is not available. on JS array. So this is how we get the name into our option tag twice, because L symbol is a JS object and it has the property name, and then we can add it to the option. Okay, so that should work. Let's try it. So we have all the years in here, and I have a nice copy paste error. That's why you should never copy paste F select symbol. I added it to the years. Funny thing, it works because it's just an option element that we add there. So now we have the years right here and the symbols right here. Perfect. So we have recreated what we need. Now the only thing we need to implement is showing the chart. And that gets a little bit more complicated because we have to insert chart.js into TMS Web Core. And I had it all in one unit first, but then I made the call to separate it into more than one unit. So what I do in show chart is basically I get the information and then I'm going to hand it off to my own chart component that I built. Okay, don't think this is going to be mighty complex. So instead, what we're going to do here is I'm going to say fchart is tchart.js. That's a control I just now create. Okay, that's the most important thing. Okay, and I create this inside of my TMS Web Core application. I add a new unit right here, and I call this unit uChart.js. Okay, that's the unit. And in there, I define a class type tchart.js. That's a class. And this is something you can do for any JavaScript library. By the way, this is not just for chart.js. You can use this as an approach to include any other JavaScript library into TMS Web Core. f_element_id is the string. I want to hand an element to this component where the chart is supposed to be rendered. Then I need a method to destroy the chart. And in public, sorry, this is all private. And in public, I need a few things. I need a constructor, of course, create. And to this constructor, I want to pass the element ID where the chart is supposed to be rendered. And I need a destructor, destroy, to clean up the chart. That's mandatory. And then I have a procedure render that I can call when I want to render the chart with the data. And the data is, of course, a TJS object that the XData server returns. You see, this is all much more structured than just implementing it in vanilla JavaScript. This is so much more structured and type safe than the solution that I presented before. And I need sysutils, user system.sysutils. And I also need, this is the most important thing in all TMS Web Core applications, I need web and I need JS as the main units, because that's where the knowledge for the web lies with TMS Web Core. Okay, and with that, I can start implementing all the different methods. So create is pretty straightforward. In create, we're just going to call the create of the base class. And then if a element ID is empty, code completion once again fails because we added a new file to the project. So I have to say tools, reload LSP server, and then you should be good to go with, yeah, it's empty. So if it is empty, we can't continue. We have to raise an exception. So we say erase argument exception create, and then I say element needs to be specified, because otherwise we don't know where to render the chart, right? And f element ID equals a element ID parameter. So I set the field to the parameter that has been called in. The destroy here is just element. I also can say destroy chart. It's a good habit. And then in destroy chart, what do I do there? Well, I keep a reference to the chart, which is just an object in the JavaScript world. So what I do is I say if assigned fchart, then begin. And this might seem a little bit ridiculous, ASM, which means I go into JavaScript. And I can only do this in JavaScript because I need to reference something that I create in JavaScript and not inside of my Delphi class or Delphi object here. So I have to dive into the JavaScript world. I have to say this fchart destroy, that is the fchart variable that I will create in a bit. You'll see that. So this fchart refers to this definition here, but the dot destroy is now available because I go into the JavaScript world. Otherwise, the compiler would be, I don't know this, and that's why I dive into JavaScript here. That's the one line of JavaScript I need in order to destroy a chart that I created inside of the JavaScript library. And the render, I'm going to make it easy. I'm not going to update or anything like that. I'm just going to call destroy chart first. And then I'm going into JavaScript again. And we need two things. We need the context, document get element by ID. And this .f element ID is the element where the chart is supposed to be rendered. That's our field right here that we passed in as a parameter, okay? So you can pass in things from your class into the JavaScript world here. And then I say this fchart equals new chart, and then context a data. And believe it or not, the a data is the a data that you pass into the render function. And that way, with those 1, 2, 3 lines, we can render any chart depending on what the data is that comes in from the XData server. Okay, so going back here, we have the tchart.js. We need to add the uchart.js unit to the users class. Then the error goes away. And of course, in order to use all that, we need to initialize our fchart.js class. And we do that in the initialize user interface, I would assume. So we go as soon as the DOM is initialized right here, before we call connect, we say fchart stchart.js. That's our component. And the element ID is, if we look at our HTML here, my chart. Okay. So my chart, that's where we want to render it. So we create it. And of course, if our form gets destroyed, events on destroy, we want to free that component. Okay, perfect. And with that, I think, thinking about this, do I have the button click implemented? Show chart and show chart. I think we have not implemented yet. No. Show chart is also declared, if I remember correctly, as async. So now we have to get the data from the XData server, right? So we say var LData response XData client response. And we say LData response equals await. And now we have the client and raw invoke async operation ID. But this time we have 2 parameters. The first parameter, and this is sadly only in order, as it is in there, the year first, then the symbol. So here we have L year and L symbol, okay? Like this. Those are the parameters, and the operation, we can look that up too in our server API, is iStock service line chart. That's what we need. So we say iStock service line chart. And how do we get the year? Well, once again, we have our selectors, right? We have the F select symbol, and we have F select years. So we have the L year, and we have the L symbol, and both of them are strings, right? We define them as strings. We can do it the following way. Or actually, let's see how we define the years in our... No, I said like string name for the symbol, and here, yeah, but I think... Let's check this. I don't know if we can use strings in both of these cases. So F select symbol is basically the L year, L symbol equals F select symbol value. And even though code completion tells us there is no value, just ignore it. There is a value, okay? And the same for L years or year, F select years dot value. It is there, even though if code completion thinks there isn't, there is. So with that, now you see we forgot one parenthesis. Okay, here, let me compile this. Okay, perfect. And if we get a response, if LData response status code equals 200, then begin, what do we want to do? LData equals TJS object, LChart response dot LData response, sorry, LData response dot result as object. And that's it. We don't need a value or anything. The result is what we need to pass to LData. Okay, and LData is of type TJS object. Perfect. And that's what we pass in to our render function inside of our chart component that we created. So we say fchart.render LData. Perfect. And with that, I think our application is complete, believe it or not. So poof, right here, we have years old, let's say 2024, Apple. Open the developer console on network so we see what's going on. So we click show in chart and we see that we don't see, right? Nothing is really happening. So the only thing I can do now is check why is nothing happening. So we go here to the button click, we call for show chart, and in show chart, let's see, we have async in there. So the next step, what you can do always is go to console, and there we see that we have an error in our application. And it occurs, and this is the strange thing here, it occurs in t-value to string result is not. So where is our error? We go down, 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 down. And here, if we go down, at some point, we get U4 main 138. So that's the line where we have our error, 138. So here is our error. So this is actually, believe it or not, supposed to be an integer here. So we look at these parameters here, L year, L symbol, and now I go over to my Swagger UI server API, and look how I define this. Symbol first, then year. So I messed up big time, okay? So the order, and this is why I did this, is something you always need to check for your parameters. You can't just rely on the data types or on what you name things. The order is what determines your parameters inside of the raw invoke async call. Okay, you have no ability to do an assignment. This is the parameter I want for that, and that is the parameter value I want for that. It's not possible. The order is determining it. And hopefully now it works. I could still encounter, because I defined one as an integer and I pass in a string, that this isn't automatic. So I don't know if that works. So show in as chart. So here, same thing. ToString is where it like breaks. So this is the second rule we have to abide by. We have to make this the year has to be an integer, because in our service definition, if we go way back up here to the source and there's the services, stock service, we said this has to be an integer, right? And as we work in a typed environment with TMS Web Core, it won't accept anything that doesn't match the type that we want to use. So here we say L year, F selected year's value, and we need to call string to int in order to make the assignment. Okay, so now L year is an integer, and that should work fine now. Now we pass an integer to the backend as it expects. So F12, and then show in chart, and there you go, it works. We have our chart for all. Let's go to 2022. There we go. Let's do 2020. Let's do NVIDIA. And if we look at the developer console again at the network request, so if as soon as I click, for example, let's say 2023 NVIDIA, we get line chart, symbol, NVIDIA here. The encoding of the URL and everything is done by the components. I can literally just focus on passing in the parameters the right way. If I do all, it should be 0, here is 0, and I get all of the parameters passed in. Perfect. That's it already. The example is complete, and I hope you saw that vanilla JavaScript has the advantage for tinkering. You can just put something together really, really quickly. However, as soon as you want robust code that is easy to maintain over years to come, TMS Web Core is the solution to go with type safety, a compiler, and also type safety to the backend that it really checks, hey, you have to specify an integer and not just a string, and then the backend just miraculously converts it automatically. No, you have to work with well-defined types, and as we've seen so far, we can also use typed objects as return values in our XData services, or we can also use JSON objects to describe something completely unknowns to Delphi, so to speak, so that a JavaScript library like this chart.js library can create a chart inside of our HTML design that we define easily. So this really was one big tutorial that showed you how flexible XData is. It showed you how flexible TMS Web Core is to use anything you want that is out there in the world of web application development. Before I do the big roundup to thank you for staying with us this long, I would like to point out that if you really, really want to go into detail, please have a look at my XData in-depth training course. This training course teaches you anything there is to know from the ground up about TMS XData. In this case, we use a Firebird database, and you learn, in addition to what you learned in this brief, I know it's not that brief, but brief overview, you learn about logging and user authentication and authorization. This is yet another big example to teach you about TMS XData, but it also focuses on you building a template for yourself for TMS XData that you can use for all your upcoming XData projects as a starting point to create all your XData web services in the future. As you can see, I've spent a lot of time to just give you a big outline what is included in this course. It's a very well-founded example from data that I extracted from my training bike. So you can really, really dig into the data, and we will build a VCL application, something we haven't done yet. We're not only going to build a web core application there. And again, we use charting with charting components in the VCL to visualize the data. You can find this on courses.landgraph.dev/p/xdata22. Or even easier, you go to Holger's Code, which is www.holgerscode.com. Bookmark that page because we have all the Delphi news. We have books about upcoming Delphi books, existing Delphi books. And of course, all my Delphi books have XData in some way or the other. The introduction is in web application development with Delphi. Multi-tier cross-platform data access and visualization goes really deep into giving you yet another deep XData example. And then here on modern software development with Delphi, we are going to use XData with Aurelius. And finally, in cross-platform multi-tier data applications, you're going to learn how to build an XData server which serves millions of records in good time that your application still stays responsive. You're going to create your own system for authentication using your own token system, not the built-in JWT system. So this is really a huge amount of information about XData that you can learn about. And as mentioned, the training course is also linked here, where you have Delphi web service with TMS XData. There's also a link and some feedback that I've gotten for this training course. So please feel free to use any of these additional learning resources. I really hope you liked this. Please give us a thumbs up and stay safe. Take care. Thank you.